In this video, we will look at differentiation. So it's differentiation. So we will focus on differentiation using power rule. And then secondly, we will look at differentiation using product rule. And then we will look at quotient rule. And then lastly, we will look at chain rule. So these are basic rules of differentiation. So let's quickly look at power rule. So power rule is the first rule that we're going to look at. So power rule is used as follows. You are given an equation that is in this nature. So this can be any polynomial function, x to the power 2, x to the power 4, x to the power any exponent. So when we differentiate this, you will say dy dx. You bring down n, and then you say n minus 1. So this is the general formula for the power rule. So we can look at an example of this. Example. Of course, we will look at a simple example. So if you have y equals to x to the power 3, if you find the derivative, so differentiating is also called finding the derivative. So dy dx, you bring down the exponent, which is 3 in this case, is 3x. Then our exponent is n, so it's 3 minus 1, which simplifies to 3x squared. So as you carry on with these and solve a lot of problems, you won't have to write this step of saying 3 minus 1, because 3 minus 1, you already know that is 2. So we can look at another example using power rule. So we can maybe say this is example 2 using power rule also. So if we have y equals to 2x, x to the power 4 plus 4x. So in this case, we can see that we cannot differentiate straight away. What we can do, we can rewrite this by multiplying throughout by 2x. So we have 2x times x to the power 4, which gives us 2x to the power 5, plus when we multiply again, we will get 8x to the power 2. So now we can differentiate using the power rule. So dy dx equals to, bring down the 5 and multiply the 2, we get 10x to the power 4. We bring down the 2 and multiply the 8, and then we will get 16x. Of course, we must remember that we must subtract the exponent after bringing it down. That's why on the final step, it was 10x to the power 4. We brought down the 5. Now, when we bring it down, we subtract by 1. It becomes 4. Even on the second term, which was 8x squared, we brought down the 2. Then 2 minus 1 is still 1, so that we end up having 16x. So that's it with product rule. Then we can carry on and look at product rule. So product, we know that from our knowledge of mathematics, product is associated with multiplication. So of course, even on the product rule, there is a formula that is used. So we can try to write a general form as follows. Of course, when you look at different sources, there will be different representation. So I found this to be convenient for myself. So y equals to f of x multiplied by g of x. So you have two functions that are multiplying each other, which are f of x and g of x. So when you carry the derivative here, you say dy dx equals to, you must differentiate f of x first. So when you differentiate f prime means the derivative of f of x. Then you multiply by g of x. Plus, now you differentiate g of x. You multiply by f of x. So now we have found that instead of writing dy dx, we can also write a prime. So because this equation was the equation of y, we can also write it as y prime equals to f prime g plus g prime f. So it means the same thing. So what we notice is that dy dx is also y prime. That's the way of writing it. So it's either you can write dy dx or y prime to show that you are differentiating y. So we can look at the example using product rule. So let's look at this. We did it by power rule by first expanding the bracket. So we can do it straight away by product rule. So if we have y equals to 2x plus x to the power 4 plus 4x, and we should get the same answer as the previous example, but now using the different formula. So here it means you have two functions. So this one, you can call it your f of x, and then the other one, g of x. So f of x is equal to 2x, and f prime, when you differentiate 2x using power rule, it gives you 2, because now the exponent is 1. When you bring it down, it's just going to be 1 times 2. Then 1 minus 1 is 0. So x to the power 0 is 1. So you end up with 2. And then the other one, we call it g, is x to the power 4 plus 4x. And g prime now gives 4x cubed plus 4, because now you have everything that is needed for the equation, because the equation says that you have dy dx, which is f prime times g plus g prime times f. So what we can do is we can substitute f prime is 2 and g is x to the power 4 plus 4x plus g prime is 4 x cubed plus 4, and then f is equal to 2x. So we have just substituted all these things inside the equation. Let's open another page where we can finish up. So because we have differentiated already, so we said that it was 2x to the power 4 plus 4x plus 4x cubed plus 4 and 2x. What we need to do now is just to distribute and get rid of the brackets. We have 2 times x to the power 4. We will get 2x to the power 4 plus 8x. When you distribute the brackets on the other side, we'll get 8x to the power 4 plus 8x. Then when we add the like terms, 2x to the power 4, 2x to the power 4, and 8x to the power 4 gives us 10x to the power 4, 8x and 8x, we get 16x. Then we can confirm that this was the answer that we got when we were using power rule. Of course, here it seems like it's a bit long, but when you are familiar with the method, it's easier. You will be able to do it within 2 lines. So moving on, we have covered power rule, we have covered product rule, and then rule number 3 is quotient rule according to our schedule. It's quotient rule. So product rule is associated with multiplication in terms of mathematics. So quotient rule is associated with division. So you will have something of this nature. You have 2 functions that are dividing each other. Then when you want to find dy dx for this function, you want to differentiate, you must differentiate the top function first, then you multiply by the bottom function, then minus. Now you differentiate the bottom function, then you multiply by the top function. All over, you must square the bottom function. So that's it that you do with the quotient rule. So we can look at an example, of course, as we've been doing like on the previous rules. So if we have y equals to 4x to the power 3 over 9x to the power 2 plus 5x. So here we can say, we can call this to be our f of x, and then the bottom one we can make it to be our g of x. So if we differentiate the top one, we get 12x squared. Now we want, because now we have already explained how to differentiate using power rule, we won't spend so much time on that. And then when you differentiate the bottom one, which is going to be g prime, get 18x plus 5. So what is needed now is to say dy dx is equals to f prime multiplied by g of x minus g prime multiplied by f of x divided by g of x squared. What we need to do now is to just substitute. Our f prime is 12x squared multiplied by g is 9x squared plus 5 minus our g prime is 18x plus 5. Of course, let's put everything inside brackets. And then our f is 4x to the power 3. So we have to not forget to differentiate by the denominator, of course, which is 9x squared plus 5x all to the power 2. So the answer here should work out if you simplify everything and distribute, because now this is not a simplifying class. We will just write the final answer. This is the final answer. You can work it out and see if you will get this. This should be the final answer. I've already worked it out. So 9 plus 5x. So this is the final answer that you get. So let's move on to the last rule, which is the fourth rule of our class, which is chain rule. Chain rule. There is a relationship between chain rule and power rule. Many texts represent it differently, of which it's a bit confusing to students. But if you have a function of this nature, of course it looks like power rule, but it's not entirely power rule. So what you did when you do when you differentiate is that you bring down the n, and then you multiply by the function that is inside the brackets, subtract 1, but also go inside and differentiate. Okay, so we will look at an example. If we have y equals to, for example, let's have an example. If we have x to the power 2 plus 4x, so now we can see that our n is equals to 3, and our f of x is equals to x squared plus 4x. So let's just do it here on the other side. So f prime is equals to, we differentiate here, we get 2x plus 4. So when we carry the dy dx for the whole thing using our formula, say dy dx, our n is 3, we bring it down, then we write f of x as it is, then 3 minus 1 is 2, then we go inside and differentiate our f of x, which is f prime. We've already differentiated. It's equals to 2x plus 4. So if you leave it like this, it's good enough. Of course, You can factorize if you want to, because here you have x squared and 4x. That side you have 2x plus 4. So explaining the rules, I think it's good enough. Then simplifying, it will depend on how the answer is wanted. More especially in mathematics, they will say simplify it to the simplest form that it can ever be, until you cannot simplify further. Thank you for tuning in.